Hey guys! So in this video, we're going to be talking about IMFs and bonding. So the types of IMFs in order of decreasing strength. So the strongest is dipole-dipole, specifically hydrogen bonding. And then we have ion-induced dipole, dipole-induced dipole, and London dispersion forces. So we'll talk about what each of these are in a second. So dipole-dipole is the force of attraction that enables two polar molecules to attract one another. So polar molecules are those that have an uneven charge distribution. So this is the what we write for the polarity. So this basically says that this side is a positive polar charge and this is negative. So that could possibly have a lone pair or just a large electron cloud on this side of the molecule that causes this attraction. So obviously, opposites attract, so the negative polar side of it would attract the positive polar side of it. So there are higher melting and boiling points since the attraction between the molecules are so strong. So the more strong of a IMF, the harder it is to boil it, the higher temperature you're going to need to boil it or to melt it. So hydrogen bonding is a specific type of dipole-dipole. This is said to be the strongest IMF. And hydrogen bonding is the force of attraction between a hydrogen atom of one molecule and an unshared electron on fluorine, oxygen, or nitrogen of a neighboring molecule. So essentially here, it has a very high boiling point and a high specific heat due to these strong forces. So in this picture here, we have water, which is the most common example of hydrogen bonding. So we have the oxygen, which has the two lone pairs here. So that negative electron cloud attracts the positive hydrogen. So that forms a hydrogen bond, which makes water hard to boil and things like that. So an ion-induced dipole is the force of an attraction between a charged ion and a polar molecule. So we have a polar molecule here, and that was a mistake. It's just polar molecule. So here we have a polar molecule where it could possibly be water and NaCl. So obviously there's a positive side of the water molecule here, and that would attract the anion, and the negative side of the polar molecule would attract the cation. So these are very strong forces too, because that's commonly happening in solution and things like that. So that is why a saltwater solution would have a slightly lower boiling point than water, but it's the ion-induced dipole that causes these forces between them. So dipole-induced dipole is the force of attraction between a polar molecule and a non-polar molecule. So this, the polar molecule induces a temporary dipole in the non-polar molecule. So as you can see here in this image, we have a non-polar molecule because it's symmetrical. So we're just going to assume in this case that it's non-polar. And when the polar molecule approaches it, it forms a temporary dipole. So the electrons will either shift to the side that's positive or negative. So if a water was approaching a nonpolar molecule as it is here, the electrons could possibly go a certain direction in order to try to form an intermolecular force, but this isn't a very strong force. So next is induced dipole or London dispersion forces. So this is the least attractive force between molecules. So the force of attraction between two nonpolar molecules due to the fact that they can form temporary dipoles. So this is what we call an electrostatic attraction here. These are two nonpolar molecules, and essentially the electrons, kind of like in the last example, are going to shift to try to form a temporary dipole or an intermolecular force, but this is very weak, so they would have low boiling points and melting points. I hope this helped with IMFs and bonding. Thanks for watching.